wrong period. All right. Here we go. Woo! Okay, here we go. All right, ladies and gentlemen, today we are dividing monomials. All right. Now, just like yesterday, I really like to focus on the meaning of exponents, okay? Because if you go back to the meaning, all of these rules come from somewhere. They're rules we don't have to memorize, right? As long as we really understand what's happening. So we are dividing monomial terms, and again, monomial is a single term connected by multiplication. And maybe, let me think about this. Let's do something similar to what we did yesterday. Maybe if we're dividing, then I'm seeing a fraction. And so maybe I have like 5 to the 4th divided by 5 to the 2nd. All right, let's go with that. So once again, I want to focus on the meaning of the exponents. What does 5 to the 4th really mean? Good. 5 times 5 times 5 times 5. Beautiful. And 5 squared really means? 5 times 5. Well, when we have a fraction, so for instance, we have a fraction like 2 over 2, how many times does 2 go into itself? It goes in one time, right? And so when I look at this fraction here, I have 5 over 5. What happens to the 5 over 5? It's 1. Yeah. So they, top and bottom, those 5s cancel out, and they really just leave behind a 1. All right? Does it happen again? Yeah, absolutely. If I have a 5 on top and bottom, then 5 divided by 5 cancels out, and we're just left with a 1. Does that make sense to you? Okay. And so what's left behind? 5 times 5. And what is 5 times 5? 25. Or I could just write 5 squared for my purposes here. And then maybe in the denominator there's a 1 there, but do I need to write divide by 1? No, I don't need to do that. So it is just 5 squared. So then the question is, how do we go instead of writing everything else? But you could always write everything out if you wanted to. Like if you were unsure, could you write stuff out and cancel things out? Absolutely. It's a great way to do things, okay? But we do have shortcuts. So what's the shortcut to just getting our answer of 5 squared? If we start here, how do we get 5 squared? You're subtracting the exponents. That's exactly right. Top minus bottom. In fact, our division, doesn't it kind of look like a subtraction sign? Like if you think about it, a little weird like me. So it is like 4 minus 2. You would have to subtract the exponents. So how do we write that down? Here is our quotient rule. Write this down, quotient rule. The quotient rule says if I have some base to a power of m over some base to a power of n. And I like to use b for the base, okay? Again, our bases must match. All right, if the bases match, then we can apply our quotient rule. And our quotient rule would be the base stays the same, and we can do top minus bottom, m minus n, which gets a little tricky when we deal with negatives. So we have to be very careful, okay? And there's lots of ways to deal with this. The other thing I want to say is just like my 5 squared was up in a numerator, I want you to understand that this result is also upstairs in a numerator. We might get a negative exponent, and after that negative exponent, then we might have to relocate it to make it happy, okay? So when you use the quotient rule, your answer always ends up in a numerator, and then we might have to adjust from there. So that's really important. All right, so again, let's talk about Number 1 here, we're going to use the quotient rule. Do the bases match? Yes. So then we get 12 to the 7 minus 5, which is 12 to the 2nd power. Can we jump right from 12 to the 7th over to just 12 squared? Absolutely. I'm just showing the steps here that we're subtracting those exponents, 7 minus 5. All right, on number 2, do our bases match? Yeah. So we keep the base the same, which is negative 6, and I'm also keeping it in parentheses. And we're going to do what minus what? 12 minus 4, top minus bottom, very good. And so that's going to be negative 6 to what power? The 8th power. Ladies and gentlemen, I'm going to ask you a little question here. What does negative 6 quantity to the 8th really mean? Negative 6 over and over and over and over again. How many times? 8 times. Ladies and gentlemen, if negative 6 is written out times itself 8 times, is this answer going to be a positive or a negative answer? Positive. How do you know it's going to be positive? No. Negative times negative times negative times negative. If I have 4 negatives, if I have an even number of negatives, what's my result going to be? Two negatives make what? A positive, okay. And then another 2 negatives make a positive. And positive times positive is still going to equal a positive. If you have an even number of negatives, we're going to get a positive result. Always, always, okay? So keep that in mind. That was just a little test here. Hey, look at this. 4 to the 10th divided by a 4. What's that going to be? 4 to the 10th. 4 to the 9th. Why is it 4 to the 9th? Yeah, everything has a little exponent. Very good. So again, this is 10 minus 1 in our exponent language there. So that's going to be 4 to the 9th. All right, number 4. Again, they have the same base. So the base stays the same. It's a 9. What do our exponents do? What should I write for my exponents? 3 minus 5. Be very careful. 3 minus 5 is going to give me what? Yeah, 9 to the negative 2. Now this is happy, sad. Is it happy or sad? Sad. And so now it goes to a denominator 9, 1 over 9 squared. If we use the rule, we're going to get, sometimes we'll get negative exponents, which then we have to adjust, okay, into a denominator. All right. Ooh, what is this? 8 to the 6th divided by 8 to the 6th. Well, let's see if they have the same base, so the base stays the same, and we're going to do what minus what? 6 minus 6, and what is 6 minus 6? 0. What is any number to a power 0? 1. Very good. 1, 1, 1. Anything to a power 0 is always equal to 1. Does that make sense? Imagine, let's go back to our writing it out idea here. If I write out 8 to the 6th, what do we have in the numerator? 8, 8, 8, 8, 8, 8, 8, 8. What do we have in the denominator? 8, 8, 8, 8, 8, 8, 8, 8. And what happens with all of those 8s? Yeah, they all become 1s because they all cancel out, right? And we're left with a 1. Okay? Does that make really good sense then? Okay? You don't even have to remember the rule. It makes perfect sense if we really think about the meaning of what we're doing. Okay? So I think a lot of teachers get too lost in rules, and I don't like rules. I'd rather we always do it the long way. Okay? Really understand what we're doing. Okay, here we go. We have the same base of negative 5. We're going to do top negative 1 minus the bottom exponent. So we have a negative 1 minus 2. What is a negative 1 minus 2? Negative 3. Very good. Happy or sad? Sad. So we're going to change it to 1 over what? Negative 5 quantity to the happy 3. The negative value of the number does not change. The exponent changes sign, okay? Ladies and gentlemen, is this going to give you a positive or negative result? Negative. Why is it a negative result? Odd number of negatives there. Negative 5 times negative 5 times negative 5. That's going to give us a negative result because it's an odd number of negatives. Beautiful. Okay, the same is true with variables, all right? So I can look at number 7. They have the same base. And what do we have to do? 10 minus 2. What is 10 minus 2? 8. Very good. And that's a great answer. Here, I'm going to write this out. W times W, because I think there's easier ways than using the rule. W squared, I know, is W times W. W to the 7th. 1, 2, 3, 4, 5, 6, 7. Of course, when I do this stuff, I don't write this out all the time, but I can see it in my head. What's going to happen when I have W times W on top and the 7 written out W's on the bottom? What are they going to do? They're going to cancel out. They reduce to ones, and so what do I end up with? What's in the numerator? A 1. Everything cancels out and reduces to 1. So there's a 1 upstairs in the numerator. And what do we get in the denominator? W to the 5th. Okay? Now, if we were to use the rule, when we subtracted, we would have done 2 minus 7. That would have given us W to the negative 5. And then, of course, W to the negative 5 we had to put in the denominator. Do you see how it works the same way? But I actually just like to look and say there's more W's in the denominator. Does that make sense to you? Yeah? So I can jump right to the answer. There's more W's in the denominator, so that's where they're going to land. What about number 9? What are we going to get on number 9? P to the negative 3 or 1 over P cubed. Very good. Again, you can think about using the rule, top minus bottom. 1 minus 4 is negative 3. Or we can think about writing it out. P over 1, 2, 3, 4 P's written out. All right, the P's cancel out, leaving a 1 in the numerator, but we get P cubed in the denominator. Which is easier for you? Do you like the rule, or do you like just thinking about who has more? Raise your hand if you like the rule. I'm curious. Raise your hand if you like the rule. Raise your hand if you like thinking about who's going to have more. Okay, all right. I like thinking about who has more. All right, let's look at number 10. They get more complicated, obviously, and I think that it's easier to just think about it a little bit. Let's look at number 10. Look at those M's. Where is the M going to end up? M to the first on the top, yeah? M on the top. And what about the N's? What's going to happen to the N's? Into the fourth? Where is into the fourth? Is it on the top or is it on the bottom? Still on the top. Yep. So how does that work with the rules? They have the same base. We would do 3 minus 2. M to the 3 minus 2 is M to the first. And so that's where that M to the first came from. And then we have N to the 6 minus 2. Top minus bottom, that'd be N to the fourth. And so we get M to the first, N to the fourth. Those are both in the numerator. Okay. All right, I'm going to do the rule for number 11. We have matching base of R. What do we do with our exponents? These are hard because now they're negative. Top minus bottom. We would do 2 minus a negative 3. 2 minus a negative 3. What is 2 minus a negative 3? Yeah, it's really R to the 5th power. All right, we got S's. A couple of S's there. They have the same base. What do we do with the exponents? Subtract. So that would be negative 5 minus 2. What would that give you? So that gives us s to the negative 7. But what do we have to do with that s to the negative 7? You have to make it happy. Yes, he is unhappy in its current location. So he wants to go to a denominator. R to the 5th stays on top, and s to the 7th goes to a denominator. Because he's a negative. Negative 5 minus 2 is negative 7. You okay there? All right. All right, let's look at number 12. We've got A's. We are going to do top minus bottom, 2 minus 9. What is that? A to the negative 7. Very good. We got B's. Top minus bottom would be 9 minus 3. What is that?
6.
B to the 6th. Very good. We've got C's. Top minus bottom. 4 minus 4 is 0. C to the 0. Now we got to clean it up. What is A to the negative 7? Where does it want to go? To the denominator. Got to go to a denominator. All right. So A to the 7th turns happy. B to the 6th. Happy or sad?
Happy.
Happy in the numerator. So B to the 6th on top. And what about C to the 0?
1.
Yeah, it's just 1. C to the 0 is just 1. So we could times by 1 if we want to, but we don't have to do anything. And that is the final answer right there. B to the 6th over A to the 7th. All right, do you have questions for me so far? Is this easy? Okay. All right, so now, a little more complicated examples here. So you'll notice we have numbers. Ladies and gentlemen, those are just fractions. You've been dealing with fractions for quite a few years now. Do you see the fraction 24 over 8? Yeah? Okay. So we need to reduce fractions like we've been doing for a long time. And we need to deal with our exponents like we just learned. Okay? So 24 over 8. Let's see. What can we divide both of those numbers by? 8? Yeah, can we divide by 8 for both of them? Yeah. Divide by 8 on both of them. Yeah, that was your answer, I know. 24 and 8 both divide by 8. Again, if you have a calculator, can you just type in your calculator 24 over 8 and then maybe math frac it? But it is just 3. 24 divided by 8 is 3. And then we have c to the 10th divided by c cubed. That's going to be c to the 10 minus 3 if we use the rule. And that would be c to what power? 7th. All right, ladies and gentlemen, what is, on number 14, negative 36 divided by 4? What is that going to give us? Negative 9. And then we're going to have k to what power? K to the 2nd. Very good. How'd you get 2? 6 minus 4 gives us the 2. Beautiful. That was easy. Boy, that's pretty easy, isn't it? Okay. All right, let's look at number... Let's look at number 15. So I see some numbers. I see 10 over 2. What is 10 over 2? 5. Very good. And then we have our x to what power? Negative 1. How'd you get negative 1? 3 minus 4. So we get 5x to the negative 1. But he's unhappy, so it becomes... Is the 5 happy? Yes, the 5 is happy. So the 5 stays in the numerator, but x to the 1st wants to go in the denominator. So 5 over x to the 1st. Okay. How are you feeling about this? Good? Is it too easy? Yeah, you're ready, huh? All right. 20 divided by negative 5. What do we get? Negative 4. And then a to the, what happens with my powers? Negative 12 minus a negative 4. Ladies and gentlemen, here is where careful matters. Okay? Negative 12 minus the negative 4. Be careful. What happens with the minus and negative? It's a plus. So I have a negative 12 and a positive 4. Who's going to win? The negatives win. The negatives win by how many? 8. Negative 8. So we get negative 4a to the negative 8. Happy or sad? All right. Is the negative 4 sad or happy? Yeah. It has its own little exponent of 1. Exponent is very happy where it's at. So negative 4 over a to the 8th. Are we good? Okay. Questions so far? No? Okay. I think they're going to not be so. Okay. Let's look at number 20. Number 20. Now, number 20, I have a fraction, 8 over 20. Does it divide evenly? No, it does not. So we have to think about reducing the fraction. What can both numbers be divided by? 2 or 4. We can divide both numbers by 4. And that's going to give me, what's 8 divided by 4? 2. And then 20 divided by 4? 5, good. All right, and so you can see 8 divided by 4, the 2 stayed in the numerator. 20 divided by 4, the 5 stayed in the denominator. Okay, now, that's my fraction. Now I got my W's. Let's look at my base of W. I'm going to do negative 2 minus 9. And what is negative 2 subtracting 9? Negative 11. So I have 2/5 times W to the negative 11. And what does that negative W to the negative 11 want to do? Go to the denominator. And so I have a fraction here. The 2 is in the numerator and the 5 is in the denominator. So we just get to put that W down with the 5 in the denominator. Does that make sense to you? Yeah. Okay. So here we have our lovely answer, which is 2 over 5 W to the 11th. All right, good. Questions on that? No. Okay. Let's look at number 21 here. Oh, no, let's look at number 22. Number 22, again, I have a fraction, 16 over 10. This isn't going to divide nice, is it? No, we got to reduce it. What can they both be reduced by? 2. Divide by 2 on top and bottom. So I get 16 divided by 2 is 8, and then 10 divided by 2 is 5. Very good. So there is my reduced fraction. But then I have m's. Ooh, this is m to the first over m squared. What do the exponents do? M to the 1 minus 2, top minus bottom. And then what about the n's? N to the negative 2 minus a negative 8. We got to be real careful there. Top, negative 2 minus the bottom of negative 8. All right. Yeah. All right, so I have my 8/5 in front. This is m to the what power? Negative 1. Good. And then n to what power? Not negative 6. 6, yeah, 6. Yep. Minus a negative turns to plus. And so we have negative 2 plus 8, which gives us a positive 6 result. All right, and then I need to rearrange. So rearranging, I have an 8 in the numerator and a 5 in the denominator. What else is gonna go in the denominator? M to the power of 1 goes to the denominator, and into the 6. N to the power of 6 stays in the numerator. Are you good with that? Yeah? Okay. You have win today? Yeah, you do have win today. I'm deciding if I want to do any more, but I kind of think I don't want to do any more. do 23, and then we'll call it. Last one. Here we go. What do you suppose on number 23 we need to do? Do the top. Very good. We need to consolidate that top up there. What can I clean up? 4 times 3. I can clean up my numbers. 4 times 3 is 12. And this is, what do we do with all those x's? Combine them. How many x's would that be? X to the 9th. Oh, gotcha. X to the 2nd times x to the 7th. They have the same base, so we add those exponents together and get 9. Now the denominator has 6x to the 6th. And what's going to happen? We can reduce our fraction there. 12 divided by 6, 2. And then we have x to the, let's see, we're going to do top minus bottom. 9 minus 6, which is x to the 3rd. And that's a great final answer there. All right, do you have questions for me? No? All right, then we'll call it. That looks good. Thank you, ladies and gentlemen.